Okay, I'm going to do a quick review of portfolio theory. Let's start. Let's define P. It's going to be a portfolio that is composed of 40%. I'm going to invest 40% of my money in stock 1, and the rest, the 60%, I'm going to invest that one in stock 2. Okay. In a simple case, then I'm assuming that every stock has different expected value of returns. Then what might be the expected value, or how can I define a portfolio in mathematical simple terms? Is can define P is going to be equal to 0.4 R1, okay, these returns of asset 1 plus 0.6 of returns of assets 2. Okay, then which might be the expected value of the portfolio returns? Then in this case it's going to be 0.4 and multiplied by the expected value of the returns of asset 1 plus 60.60 multiplied by the expected value of the return of asset 2. Okay, then this is pretty simple. Then I can see that the expected value of a portfolio is a weighted average of the expected value of the single assets that compose the portfolio. Okay, then but what about the variance or the risk of the portfolio? How can I measure the risk of the portfolio? Now, one way to measure the risk is measuring the variance of the portfolio. Okay, then in this case the variance is the square of the standard deviation of any variable. Then if I consider that the returns of each asset as a random variables, then the returns of the portfolios are also random variables. Then I can calculate an estimated value for the variance of the portfolio. Okay, and the variance of a portfolio, if I applied basic probability theory, then I start with this function first, with this one. Okay, this is the equation 1. Okay, I start with this. Then if I apply the variance to this mathematical combination or linear combination, then I will get that the variance of the portfolio is going to be the variance 2 of 0.4, the return 1, plus the variance of the 60.6 return 2. In this case, there is something interesting here. When I'm working with a combination, a linear combination, the probability theory says that if I apply the variance of that linear combination, then it's going to be equal to the sum of the variance, and also it's going to be plus 2 times the covariance between both random variables multiplied times 0.4 multiplied times 0.6. Okay, this is just the way it is just because the application of simple probability theory. I explained this in more detail in my lecture note. Then if this is the case, then the variance of the portfolio then is going to be equal to when I have a constant inside the variance, I can just extract the constant and raise it and square it. Okay, then it's going to be variance of return 1 asset 1 plus 0.6 square times the variance of asset 2 plus the same thing. 6 times 4 is 24, then it's going to be 0.24 multiplied by 2 multiplied by the covariance of return 1 and return 2. Okay, then this is the formula for the variance of the portfolio. Then the risk of the portfolio is just the standard deviation of the portfolio, that is basically the square root of the variance. Okay, of the portfolio, sorry. Okay, this is 1p. Okay. Then how can I compute the variance of two random variables? Basically, the covariance, the variance of I'm going to start with the variance. To define the variance of a random variable is basically an average of deviations from the mean. Then this is basically 1 divided by n of the sum of every historical return of asset 1 minus its mean. Okay, 1 over 2n. Okay, the same thing applies for variance of return 2. Okay, we basically the same formula but only applying for asset 2. Okay, 1 to n. Then what's going to be the formula for the covariance? The covariance between two assets is basically another average, but of the sum of products of deviations. Okay, and it's 1 times e minus its own mean multiplied by return 2 minus its own mean. Okay, basically that is the definition of the covariance. Okay, I'm going to stop here, and next one I'm going to explain more.